All right, let's talk about the periodic table, but forget dusty old chemistry class. Today, think of it like a neighborhood map, and we're about to knock on the very first two doors. This is the S block, and it's home to two elemental families with some serious personality. We're talking high energy, super reactive members, they're more stable siblings, and yeah, even a couple of rebellious oddballs. So, here's our game plan. First, we'll get the lay of the land, see what this blog neighborhood is all about. Then we'll meet the two main families, the super energetic alkali metals and their much calmer neighbors. We're even going to call out a couple of the family rebels who refuse to play by the rules. And then, for the grand finale, we'll see how all this family drama is playing out inside our own bodies right this second. So if you picture the periodic table as a giant city map, every section is a different neighborhood with its own unique vibe. We're starting our tour way over on the left-hand side, in the very first neighborhood on the block, the S block. Okay, so what could a spectacular fireworks display possibly have in common with the electrical signals firing inside your brain? I know, it sounds like a weird riddle, but the answer is exactly the same. The elements right here in the S block. Turns out they're the stars of both shows. So what actually defines this neighborhood? What makes these elements family? Well, it all comes down to their electrons. For every single element here, their outermost, most important electron is hanging out in a specific path called an s-orbital. And that one little detail, it's like their family's DNA. It basically dictates their entire personality. Let's meet the first family on this street, the alkali metals. I'm telling you, if this group were a person, they'd be that friend who is just a lot. Super high energy, a little unstable, and always looking to start a reaction with, well, pretty much anyone. And here's their whole deal. They have just one single electron in their outer shell. Think of it like a game of hot potato. They are desperate to get rid of that electron and pass it to someone else. It's the only way they can feel stable. And that desperation is what makes them so unbelievably reactive. So here are the family stats for group 1. You've got lithium, sodium, potassium, familiar names. They all want to ditch that one electron, which leaves them with a positive charge of +1. And get this, they're so soft you can literally cut most of them with a butter knife. Their reactivity is just off the charts, and it actually gets even more intense as you go down the group. Why? Because the bigger the atom gets, the further away that lonely electron is from the center, making it way easier to just give away. Okay, let's pop over to the house next door and meet the alkaline earth metals. You can think of them as the calmer, more put-together cousins of their wild neighbors. So what's their secret? They have 2 electrons in their outer shell. Having 2 to give away instead of 1 just makes them a little more self-contained. Don't get me wrong, they're still reactive, for sure, but they're not quite as frantic to find a reaction partner as the folks in group 1. Now, this group has some big names too, like beryllium, magnesium, and calcium. They'll typically lose both of their outer electrons, giving them a +2 charge. And you can see the difference. They're physically harder and just a bit less reactive than their neighbors. A little more stable, a little more predictable. So we've got these 2 families, and they have some pretty similar traits. If I gave you a mystery metal from the S block, how in the world could you figure out which one it is? Well, it turns out each one has a totally unique and very colorful signature. The secret is you just heat them up. When you stick these elements in a flame, their electrons get super excited and they jump up to a higher energy level. But they can't stay there. As they fall back down, they release that extra energy as light. And here's the cool part. Each element gives off its own signature color, like a unique fingerprint. Lithium burns a beautiful crimson red, sodium a super bright yellow, and barium a crazy apple green. This, right here, is literally how fireworks get their amazing colors. Now, these colorful fingerprints are great for telling family members apart, but, no family is perfect. Even in these really well-ordered groups, there are always a couple of members who just refuse to follow the rules. These are the family rebels. And the biggest rule breakers are the firstborns of each family. Lithium in group 1 and beryllium in group 2. They're way smaller than their siblings, and that small size gives them some really unique properties. It makes them act completely differently from the rest of their family. Take lithium. It's the hardest and lightest metal in its group, but weirdly, it's also the least reactive, which totally goes against the family trend. And because it's so tiny, it can team up and form compounds with elements like nitrogen, something its bigger siblings just can't pull off. It really does play by its own rules. And it's the exact same story for its next-door neighbor, beryllium. It's the hardest in its group, with the highest melting point by far. But the biggest difference? Instead of giving its electrons away like the rest of its family is supposed to, it often prefers to share them. It's another classic case of the firstborn just being a little different. So, this has been a pretty fun tour of a chemical neighborhood, right? But this isn't just about cool lab reactions or pretty fireworks. This is where the whole story gets personal, because all of this chemistry, it's happening inside your body as we speak. No, seriously. Key members of these two families, the alkali and alkaline earth metals, are absolutely essential components inside you, running the actual machinery of life itself. Just look at this thing. It's called the sodium-potassium pump, and it's a tiny little machine found in almost every single one of your cells. It uses two of our alkali metals, sodium and potassium, to create a tiny electrical spark. And that spark, it powers every single thought you have, every muscle you move, and every single beat of your heart. It's one of the most important engines in all of biology. It really all comes down to this. The movement of these S-block elements is life. Sodium and potassium ions create the electrical pulses that send your nerve signals. That's the brain part of our riddle from the beginning. Potassium is also non-negotiable for your heart and muscles. And magnesium, from family number 2, it's a critical player in hundreds of reactions in your body, and it's even the central atom in chlorophyll, the molecule that lets plants eat sunlight, powering nearly all life on this planet. So, the S-block, it's not just a couple of boring columns on a chart. It's home to the elements that paint the night sky with fireworks, drive some of the most powerful reactions, and literally generate the spark of life. These two families lay the entire foundation. Which really makes you wonder, right? If this is what the very first neighborhood is up to, what in the world are the rest of them building?